So let's go ahead and start 3-4. So if a polynomial of n degree is greater than 0, so basically this is like a fundamental theorem right here. I want to say, let's see. Yeah, it's a fundamental theorem of algebra, so it's like a pretty big deal. Basically, it's saying that if you have a polynomial where the degree is n, obviously n is bigger than 0, then f is at least 1 0 in the complex number system. So basically, you're guaranteed to have 1 0 if n is greater than 0, if your degree is 1 or more. But that 0 could be imaginary because it says complex number system, right? So you're not guaranteed a real number, but you're guaranteed a 0. So number 2, the blank states that if f of x is a polynomial of degree n, then f has precisely n linear factors. Okay. Nope, this is not the same thing. Okay, number 2, the linear factorization theorem states that if f of x is a polynomial of degree n, then f has precisely n linear factors. So that's a pretty big deal. So if you have a quadratic, then you are guaranteed 2 factors, but they could be complex, imaginary factors. Right, when we say complex numbers, we mean the numbers with the I piece, right? It has plus or minus bi or something like that. But if you have if you have a degree n, then you can technically find n factors in the complex number system. Okay. All right. So number 5, they're basically saying, you know what? Find the zeros using the synthetic division. Now, there's a way to find all the possible zeros. So what you do is you take the constant term and the leading coefficient, and you find every possible number, divide them, and create a list of possible zeros. So you're kind of going to do trial and error and do synthetic division with those possibilities. So before in the other sections, we said, hey, this is a 0, so therefore it will divide evenly, right? Or they would say, use this to do synthetic division, but this time they're not telling us. So let me write this question down. 3.4. Zeros of polynomial functions. Okay. Determine, this is number 5. Determine actually it just says determine the number of zeros, so my bad. I thought I said find them. So how many do we have? All right, let's look at the before we go any further, for number 5, at most we could have 3, right? Because we have a cubic. So over here we said fundamental theorem. So you have at least 1 0 for degree n. So our degree is 3. So we know for sure we have 1. And we'll have 3 factors. But remember, sometimes they can repeat. So we can't say that it'll be for sure 3 zeros. So we're going to need something else. All right. One moment. Let me find it. Let me pull up the notes real quick. So basically, if your degree is 5, then you have 5 zeros. It doesn't mean that they are distinct. They could be repeated, they could be imaginary, they could be whatever. They could all be different. But technically, you can still say there's 5 of them. So 7 would be 7, etc. Does that make sense? Okay. So there's no real work. It's more of a conceptual thing. Yeah, basically just take the highest degree. Like check out number 8. Here you can see that the 0 is -5, but it's repeated twice, right? So technically it'd be the same 0 just twice. So that's how I'm taking it. So I would say that, well, there should be 2. Does that make sense? Okay, cool. Number 9 is the same deal. Well, let's see. The degree would still be 2. I think they're just messing with our head because it looks like there could be more, but it's just the highest is still 2. It's not. Interesting. So if you were to multiply this out, oh, I see. If you multiply this stuff out, I think some terms may cancel. So expand the square on both. We'll end up with, I think the t's canceling out. So it's going to be 0 or 1, I think. You want to work this one out? Okay, let's do it. Okay, number 9. Turn number of zeros for h. I'm gonna use x just because my t's look stupid. All right, let me switch back. So basically expand this. So multiply these 2 times and you're gonna get x squared, x times 9, it's gonna be minus 18x plus 81. Expand this one. Then we'll leave this one in parentheses because there's a minus in front. To multiply this out twice, square it, you're gonna get x squared plus 18x plus 81. So distribute your negative, and you'll get here, right? So what's going to happen? '81s will cancel, the quadratics will cancel. 18 minus 18, that's going to be what? 36, all right? So now what degree is this? So we
1.
should, yeah, right? So how many zeros we got?
1.
1. So we just had to expand it so we could see it better, because at first glance it looks like it doesn't matter, but stuff canceled. Okay. Now we have, so any questions on number 9? Is that okay? Okay. So use a rational test to list the possible zeros. So this is the technique I thought I wanted to do for the first one. So what you do is you take the constant, the number 3, and the leading coefficient, and you divide them. Okay. I think I pulled up the notes earlier here. So basically, factors of the constant term divided by all the factors of the leading coefficient. So let's take the 6, find all the factors, and then the leading coefficient is a 1, right? On the x to the 4th. So all of the factors of 6 divided by all the factors of 1, which is just 1, gives you this list here. That's it. Okay, so let me show you what I mean. So leading the constant term is, right? Let me write down. I'm going to write this little part down for you. Possible zeros is equal to possible rationals, so they said. So this does not include the complex numbers, the imaginary types. Rational zeros. The factors of constant term divided by factors of leading coefficient. Do you guys remember what leading coefficient meant or means? Right, it's the coefficient on the highest power. That's all. Okay. So number 10, write this down real quick, and then I'll switch over. All right. So the possible zeros, right? So look at the factors. Possible rational zeros is equal to all the factors of the constant term. So let me see, it's the best way to write this. Plus or minus 1, comma, plus or minus 3. Leading coefficient is a 1, so just plus or minus 1. So the answer would be these combinations. You do 1 over 1 and 3 over 1. So the possible zeros are 1, plus or minus 1, and plus or minus 3. So that's what you get here. So 1, comma, negative 1, comma, negative or 3. That makes sense? Yeah. Yeah, the graph will help you, it's true. But you need to make sure you know how to find the possible zeros, because
I think he means the notes on the paper, like the work.
oh yeah, of course. All right, so you guys, no questions on this first one. So like if the leading coefficient was a bigger number, then you would have a bunch of a lot more combinations on the bottom, which will result in a lot more possibilities. It will always be plus or minus. Yes. Well, this one's kind of lame. This is a good one. See how there's a 2 now? Yeah, let's do this one. Possible zeros. All right, we're not finding the actual zeros. The graph tells you the actual ones, right? But we want the list of possible. So the possibilities I wrote down, only a couple will work. Okay, so number 12. F of x is equal to 2x to the 4th minus 17x cubed plus 35x squared plus 9x minus 45. All right. the possible rational zeros will equal 2. So take all the factors of 45. So that'll be what? Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus, what else? 9, right? Plus or minus 15. Any other factors of that of 45? Yes. Oh, obviously, right. You see, as this number gets bigger, then we have more possibilities. Now divide by the factors of the leading coefficient. So plus or minus 1, plus or minus 2. So now you're going to divide the 1 by 1 and 1 by 2 to create a couple of possibilities, then 3 by 1, 3 by 2, 5 by 1, 5 by 2. It's going to create a bigger list. Some of them will reduce to become a factor you already have. So you wouldn't write it again, right? Like for example, I don't know if it'll happen with this one. No, I guess we're good here. But yeah, if anything repeats, don't write it again. So the answer, right? It's going to be plus or minus 1 over 1 and 1 over 2. Three over 1, which is 3. 3 over 2. 5 over 1, which is just 5. 5 over 2. 9 over 1. 9 over 2. 15 over 1. 15 over 2. Running out of space. 45 over 1. 45 over 2. So I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 possible zeros. Does this procedure make sense?
Yes, sir.
The 1 came from the factors of 2. The only way to get 2 is 1 times 2. So like if this was like a 6 or a 4, they're gonna have a bunch more down here, which will then increase this list. So eventually, I think in the next couple of examples, we're going to try to find the zeros by just guessing, using one of these on the list and say, okay, well, one of these got to work, or a few of these should work. So start attempting it. But you can see on the graph that we're only going to have, I think, what? 1, 2, 3, 4. Looks like 3 for sure would work. I think it's 3. It's hard to tell. Could be a fraction. One of the fractions might work. So if you were gonna try to find them, you would cycle through the possibilities using the synthetic division. So here's 13 is when they start making us find it. You guys cool on 12? On number 12. All right, let's start the next one. On the next one, we're gonna create the list and then just cycle through until we find one that works. Which can be annoying, but. Oh, let's see. Well, they want us to write the list of possible zeros, so I'm pretty sure we would write all of these with commas. Like 1, comma, -1, comma. Etc. Yeah, I know. That this one just happens to have a lot of them. So let's get it wrong on purpose so we can see what the answer looks like. Make sure I'm not lying to you. Tell me the answer. Wait, do I have infinite tries?
You have to submit different numbers every time, otherwise it won't count it.
Oh, that's right. Whatever. There's 3 tries, right?
Yeah, it's the choice.
Come on, yeah. This would be. Yeah, those are all the numbers I wrote down. So number 12 will have just a lot of them. 11 won't have as many. Well, kind of. 10 is a lot more chill. Okay. But anyway, the idea makes sense. That's what matters. Okay. 13 it is then. Find the rational zeros of the function okay. All right. So it's possible zeros. It's gonna be all the factors of 30. So 1, 2, 3, 5, 6, 10, 15, 30. Did I miss any? I think we're good, right? All right. Now use synthetic division and just try one of these numbers, see which one gets you a 0. Now, the beauty of this, right, is as soon as you find one, you can apply the quadratic formula. So you don't have to keep guessing. Although, or maybe we could factor some other method. Who knows? So let's get started here. Life sucks. It's all good, but x cubed. There's no quadratic term. You notice that? You got to put a placeholder. Linear constant. So let's choose something easy. I'm gonna choose 1 because I like 1 is easy to deal with. The rule says you bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is still 1. Negative 31 plus 1 is negative 30. 1 times negative 30 is still negative 30. This is negative 60. Looks like we almost had it. I'm thinking maybe negative 1 works. Also, you guys see that the possible zeros is just going to be the top part, right? Because dividing by 1 doesn't do anything. Okay, bring down the 1. Negative 1 times that is negative 1. Negative 1 plus that is negative. Negative times negative is a positive. Negative 31 plus 1 is a negative 30. Negative times negative is positive. There we go. Cool. We found one. So that means that x equal to negative 1 is a 0. They only wanted the zeros, right? They didn't say anything else. Yeah. Okay. So another extra note, since x equals to negative 1 is a 0, then x minus that number, which is equal to x plus 1, is a factor. And remember that these are going to be the coefficients of the factored form. So this becomes x plus 1, right? Comes out. So this becomes these numbers. X squared minus x minus 30. You see how we use synthetic division to factor a cubic polynomial? So now it becomes a quadratic. So I pulled one linear factor out. So this technique will let you factor higher degree functions or polynomials. Does this factor pretty? This guy right there, the quadratic part? Yeah, it looks like it, right? Yep. Okay, so what are my zeros?
Isn't it -1, -5, and 6?
Yep. There they are. I skipped a minor step there here, but are you guys still with me? Any steps not make sense to you? All right. Okay. So you guys are cool on 13.
Yes.
Alrighty. Excuse me. Let's do 14, then we'll move on to something else. Well, is that well, maybe 16. That looks harder. Find the rational zeros of f of x equal to 3x cubed minus 19x squared plus 33x minus 9. Okay. All right, so possible zeros. It's going to be plus or minus 1, plus or minus 3, plus or minus 9 over plus or minus 1, plus or minus 3, which is going to be, possibilities will be 1 over 1, 1 over 3. I don't have space here. I'll just do it down here. So 1 over 1, 1 over 3, 3 over 1. 3 over 3 is a 1, so we don't write that one again. 9 over 1 is 9. 9 divided by 3 would be 3, so we don't write that one either. Does that make sense? Okay. So let's start testing. I'm going to try 1 just because it's easy. There's 3, 2, 1, 0. We got all our powers, so just go ahead and write 3, 19, 33, 9. Bring down the 3, 1 times 3. This time, add them up. Negative 16, 1 times this. Okay. 33 minus 16, what is that? That's 17. Yeah, it's not gonna be 0, is it? Okay, we'll try something else. Maybe -1, I don't know. Feel like no, but it's all good. -1 times 3. Add these up, that is a negative 22. Multiply them. Add them up. No. Not gonna happen. Okay. Let's try 3. All right, bring down the 3. 3 times 3 is 9. Add that up, that's a negative 10. That times this is negative 30. Add that up, that is a negative, no, positive 3. There we go, finally. Cool. So since x equal to 3 is a 0, then x minus 3 is a factor of f of x. So that means we can factor this guy. Into x minus 3 times these pieces. Now we have a quadratic, so we can use all of our quadratic techniques that we've done many, many times. I think AC method might work. 3 times 3 is 9. Yeah. Let's ignore this guy for now. Yeah, it looks like it'll AC will work. Excuse me. I skipped the AC method. If you want to see some more steps, let me know. Or I'll do the factoring somewhere else. It looks like we have a repeated 0. Okay, so the answer will be 3 comma 1/3. Yeah, third. The step I haven't shown is you set each part to 0 and solve, right? X minus 3 squared equal to 0. The answer has to be 3. This is my side work over here. 3x minus 1 equal to 0. Solve for x and you'll get 1/3. Any questions on any of the steps for 16? Or if you need more details, let me know. That make sense? Just real quick from the top. Find possible zeros, try them out until you find one. If you end up at a quadratic, use quadratic techniques. So once we found it, we end up with the quadratic. Use whatever quadratic technique you want here to solve for x. Those would be the zeros. Since they didn't say we had to factor, you could have just used quadratic formula right there. It's up to you. But if they said they wanted the factored form, then you want to do this. I think might be later. Let me see. 17, so we've done that already. T looks different. All right, before I move on, you guys cool in 16? Okay. All right. So 18 says, well, here's two zeros. Find the polynomial with that would have those zeros. 4 and negative 3i. So the only thing you need to know is if you see an imaginary part, those always come in pairs, right? Do you remember when you do the quadratic formula, you end up with like plus or minus 2i or something weird. So there's that plus or minus guarantees two pairs. So let's see if it's here. Conjugate pairs. So if you have a zero that's x minus I, then you should have an x plus I. So if a plus bi is a zero, then a minus bi has to be 1, 2. Okay? So that's what they're saying here. Check out example 3. 3i is a zero, so that means that negative 3i must also be a zero. And we also said that if a number is a zero, then you can write it as x minus each of those. So x minus 1, x minus 1, sorry, x minus a negative 1, x minus a negative 1, x minus 3i, x minus negative 3i. So you would end up with this bottom line. So here we should have x minus 4, right? Because it's always x minus the 0, x minus 3i, or negative 3i, which would be plus, right? You see what I'm saying? X minus 3i. So obviously minus minus should just be a plus. So this is a function that would technically give me, technically has those zeros because we said if they're zeros, then they can be written as linear factors. So I can just write them as linear factors as my answer. The only thing is, I don't know if they want me to multiply it out. Is there any questions on that idea on 18? Okay, I'm assuming you guys are good. So over here we have 9 twice, so that means we have x minus 9 2 times. X minus 1 plus I, which technically should be written like this. X minus 1 minus I. But they probably want us to distribute the minus. But you do see how this is the conjugate pair. 1 plus I and 1 minus I. I don't know if it'll take this, but I'm going to try. Nice. I don't have to multiply it out. Cool. So now there's many different possibilities. There's an infinite possibilities, infinite number of ways to satisfy this question, 18 and 19. because technically I can put any number in front, so we can call it A. So A times these factors satisfies this requirement. So eventually they want a specific one. The only way to get a specific one is to have a solution point. So what you do is say, okay, well, here are the zeros, x minus 4 is x minus minus, right? And then 1, so that would be x minus 1. Here we have x minus I and x plus I. So we need to solve for A using this solution point, okay? Number 20. Find the polynomial with real coefficients that has the given degree. Given degree, zeros, and solution point. All right. So I wrote x plus 4, x minus 1, x minus I, with an A on it. You guys cool up to this point? You understand how where this part's coming from? One second. All right. Now, if you multiply all this out, well, I don't know if I really want to do that. Let's try plugging it in instead and trying to solve for A. That might be easier. We'll see. So it says at 0, we have negative 16. So f of 0 0 plus 4, 0 minus 1, 0 minus I, 0 plus I. So that'll be A times 4 times negative 1 times negative I times I. It's a little easier once you plug in the zeros. So I times I is negative 1, with another negative is positive, times the negative 1 is negative again. So this is negative 4A. And we know that this is equal to negative 16. So solve for A would be Negative 16 divided by negative 4, so that is 4. So this is a specific polynomial that has these zeros, goes through here, and will be degree 4. I'm hoping I don't have to multiply this out. Come on, polynomial. Nice. Any questions on 20? Hmm? No, A is just the coefficient. So basically, this is helping us determine a specific polynomial that incorporates the solution point. The degree refers to number of factors. So we got 1, 2, 3, 4. So that's 4 factors, 4 zeros.
I'm a little confused in the end where you put the equals negative 4a. After that, I got a little bit confused on how you got there, like afterwards.
Oh, right here?
Yeah,
Like how I got to there?
yeah.
Okay, yeah, no worries. Here. So the first thing you should remember, we understand that f of 0 equal negative 16 means that this is my x value and my y value, right? So that technically means that this whole thing, when I plug in 0, would equal to negative 16. So that's there along the way technically, but I didn't write it until the very end. I said, okay, well, now we need to solve for it. So these cancel, leaving me with a equal to 4.
I'm good now. That made more sense. Sorry. Thank you.
Yeah, no worries. Well, as long as it makes sense. Alrighty, we'll stop here for this section. Do you guys have any questions on the other sections? You're doing all right? I need to find a better schedule. Okay. I'm hoping at this point that you're preparing for exam 2, or I think maybe a couple of you have already taken it. I don't know how many. But exam 2 is all the way up to 3.1. So P6 to 3.1. But I already did 3, 2, 3, 3, 3, 4. So we're a few sections past exam 2. Okay. And I should have exam 1 ready real soon. That whole, what's it called? ISLO requirement from the school really slowed me down. They want me to do all kinds of paperwork. I'm hoping at this point everyone's done it because it's a big deal and they're gonna get upset if we don't. But anyway, if you guys are good, then let me call roll and we can call it a day. Okay, is Abdallah here? Okay, Noman,
Here.
Daniel Aguirre,
Here.
Trevor Brown, Joshua Correa,
I'm here, sir.
Megan Dean,
I'm here.
Madison Duarte, Ella Dunlop, Stephen Fogel. Oh, there's Ella. Alexander Garza. Here. Jorge Guevara.
Here.
Tyler Just. Juliana Manila.
Here.
Victoria Mannion.
Here.
Jose Mauricio.
Here, sir.
Victor Ramirez. Jaden Ramos.
Here.
Julene Cias. Miranda.
I'm here.
Villanueva. Oh, there you are. Miranda, you here? Okay. Carlos.
Here.
Frederick White.
Here.
Dylan Dylan Willis. Excuse me. All right, guys, if you have no questions, then we'll call it here. And we'll continue Wednesday. We just keep on going. Have a good night, sir.
Sir, I had a question.
What's up?
So I know I think on the syllabus you said that that late assignments are that there's no penalty for late assignments, right?
Correct.
But does the exam lock after midnight or?
They do lock after midnight, yeah. You got to start like at a couple hours before. If you start at
Okay.
11:50, then
Yeah. Okay.
they'll lock.
Okay, that was all. Thank you.
Mhm.
Have a good night.
You too. Yeah, I kind of hear Dylan.
Okay. I have a question, but it's over a different section.
Okay. Give me one
It's
second.
over. Okay, you're fine.
What's your question?
It's about 3.1. Like it's over because I'm confused on it. I tried to look through the meeting recordings, but I couldn't find where we did 3.1,
Oh, let me
and I
see.
was like extremely lost.
Okay. 3.1 was got
Quadratic functions and models. It was like everything 9 and after, I was lost. Had no
okay.
idea what I was doing.
Let me open it up.
And I figured that that's going to be on the test, so I was like, I need to ask first before I do it.
Okay, this guy, right? This section.
Mm-hmm.
Yeah, I think, I mean, I did, honestly, I don't know, I'm pretty sure I recorded it, but we didn't go into depth. But everything made sense until the end, you said?
Until like after 9.
Oh, after
I got
9.
the stuff at the beginning, but yeah, then after 9 it was I was like I was putting it into a graphing calculator and like getting the vertex and axis of symmetry and stuff, but that's the only way I could do it. I didn't know how else to do it.
Well, there is a formula that helps you find the vertex.
Mm.
Let me see if it's in the notes. If not, I'll write it down for you. Yeah, Fogo, I'll open them up again at some point. Right now, I kind of want you to focus on test 2, if possible. Just do the review over and over for now.